let us solve one more very interesting question, numerical based on pulse code modulation. And the question states that we have a sinusoidal message signal and we convert it to a PCM signal using a uniform quantizer. By uniform quantizer we mean that when we level or when we partition the amplitude axis, the interval, the quantization interval for each level is fixed. That is why we are calling it uniform quantizer. Okay, next, the required signal to quantization noise ratio at the output of the quantizer is 40 dB. The minimum number of bits per sample needed to achieve the desired SQNR. So this is the question. So if you remember that signal to quantization noise ratio is given by average signal power divided by average noise power, and we have derived that the quantization noise power is del square by 12, that is mean of square error. So it is del square by 12, where del is the quantization interval, and that depends on the peak to peak value of the message and the number of levels. So if since we are taking a sinusoidal signal, so we can, the signal is like this, and this is the peak value of our sinusoidal signal, and so delta will be 2 MP divided by M max minus M min divided by L. So del square is this. We have just shifted 12 to the numerator, and average signal power, we know that for a sinusoidal signal the average signal power is the amplitude square divided by 2. So this is the average signal power. So if we solve it, the signal to quantization noise ratio for a sinusoidal, particular sinusoidal signal is given by 3L square by 2, or equivalently 1.5 L square. Now the question states that the required SQNR must be 40 dB. So in order to get this 40 dB SNR, what should be the minimum value of level, number of levels? Because if you increase the number of levels, of course the SQNR will increase. You can simply see that SQNR is directly proportional to L square. So since we require 40 dB and we know that 10 times in linear scale is 40, so the SNR is 10 to the power 4, that is 10,000. So 3L square by 2 is nothing but 10,000. So if we solve it, we get that L is 81.6, though it is not in it should be a whole number, right? So of course we should take L more than this. So our L required should be greater than equal to 81.6. Now the question is, what is the minimum number of bits per sample needed to achieve this required SNR? So L required must be greater than equal to 81.6, and if you remember that once we perform encoding, binary encoding, the number of bits are log 2L. So we can replace the required number of bits should be greater than equal to the power n, should be greater than equal to 81.6. We have just replaced L with 2 to the power n. So if we solve it, n should be greater than equal to log 2 81.6, which is 6.35. So our n should be greater than equal to 6.35, and you know that n is the number of bits, so it must be integer, right? 2, 3, 4, 5, 6, positive integer. So here we should take at least 7 number of bits in order to achieve the SNR of 40 dB. So if we take 7 number of bits, what would be our SNR? The actual SNR? 1.5 L square, and L is 2 to the power n, since we are taking 1.5 into 2 to the power 14. You just can see that the actual SQNR will be more than 40, it will be around 42 I think. So, since we cannot take n as 6.35, we can either take n 6 or 7. So, if we take n as 6, the required as the SQNR which we get at the output of our encode, our PCM system would be less than 40, but we want our SQNR to be more than 40. So, we have to take at least 7 number of bits, or equivalently we have to divide the amplitude level to 2 to the power 7 number of levels. Thank you. If you just see, I mean, this will be more than 40. Okay.